Okay, welcome to the first video on permutations and combinations. I will be recording a series of videos where I explain to you each of these um, ideas individually. So the first idea that we talk about when we're discussing permutations and combinations is the number of ways to do a certain task. Okay, and let's explore that idea separately um, to do a certain task. Okay, so let's say I add a page and I say that for example, how many ways are there of selecting an outfit if you have four shirts and three trousers to choose from? Okay, so the simple answer to this question is that there are 4 by 3, which means there are 12 outfits. So where each different shirt that you have, you could pair a trouser with it. So for the first shirt, you can have a black trouser, then a brown trouser, and then a blue trouser, for example, and that would give you 12 different outfits. The same idea applies to, for example, this. How many ways are there of selecting a meal if you have three starters, four main courses, and two desserts to choose from? Okay, so the idea then is that there are 3 by 4 by 2. That means there are 24 different meals that you could create, each with at least one dish that is different, and none of those meals will be the same. So 24 different people could have completely, not completely, but different meals. One of the dishes, or two of the dishes, or three of the dishes could be different in those meals. Okay, so what you are inherently doing is that here you are selecting one shirt. So we call that 4C1, and we'll talk about this in a little bit. And you are selecting 3C1, and till you complete, you keep multiplying. So 4C1 into 3C1 gives you 12 on your calculator. Okay, so if you are using your calculators, you should know where this C is on these new Casio calculators that you have. um, what you can see is that there is catalog, and if you go to probability, you can write combination from here, and you can write 4C1 into 3C1, and that should give you 12. Okay, so that is how we'll be calculating all of these. um, Make sure that you know where it is on your calculators. Different calculators have it in different positions. This one has it inside the catalog function. Okay, so the basic idea is clear that when you are thinking about combinations, you are choosing your required number of objects, in this case one shirt and one trouser, from a number of different objects that are available. So when you are doing combinations, you are talking about NCR, where N is the number of objects available, the number of objects available, and R is the number of objects to be selected. So far I haven't told you, I just told you about the number of ways to do a certain task. Now those number of ways can also include arrangements. Okay, so the number of ways of, let's say, arranging five people in a straight line, that would also be the number of ways of doing a certain task. But arrangements fall into this category called permutations. Right now, what we are talking about is combinations, which refer to just selection. So in the previous example, what you were doing was you were selecting one shirt out of four, you were selecting one trouser out of three. You weren't arranging the trousers or you weren't arranging the shirts, you were just selecting out of them. So that is a case of combinations. So whenever you are dealing with permutations and combinations on your exam, remember that it's about figuring out first whether you are doing selections or arrangements, and that's going to give you a head start on the question. For now, in this video, what I will be doing is I will be doing a lot of combination questions. Okay, so let's begin with the first question. It says a school council of six people is to be chosen from a group of eight students and six teachers. Calculate the number of different ways that the council can be selected if there are no restrictions. Now, these numbers at the end are basically answers that we're going to verify. So let's start with the first question. It says, I want to select a council of six people. So I want to select six people out of a total of 14 people. There's no distinction between students and teachers. There are no restrictions as such. They'll be there in the next question. We'll talk about that. Okay, so there are 14 people who are available. And how many do I want to select? I want to select six. So let's calculate 14C6 on our calculators. That's 3003. Okay, that's what we were looking for. So there were 14 people available and six people were to be selected. Let's talk about part two. There must be at least one teacher on the council and more students than teachers. Okay, so students, teachers, let's write that down because there is a restriction now. Okay, okay. So my usual way of doing it is to write the total number of people available on top. So 8 and 6. Now what do I want? I want at least one teacher. So at least one teacher means one teacher or two teachers or three teachers and so on. So what I am thinking about is a lot of cases where I could have, let's say, one teacher first, and I could have five students alongside because I need a total of six people for the council. Okay. Then in the second case, I could think about two teachers and I could have four students. Okay. And I also need, there's another restriction. It says more students than teachers. I need to remember that too. Then I could have three teachers and three students, but that's equal. So that doesn't fit. So I'm going to cancel that out. Okay, so I have basically two cases that fit my criteria, and I'm going to use those two cases to now create combinations. How will I create combinations? I'm going to say 8C5 because 5 students out of 8 into 6C1. I keep multiplying till my council is complete. Then I add the next case, 8C4 into 6C2. Okay, let's verify if we have the correct answer. 8C5 into 6C1 plus 8C4 into 6C2. I'm getting a total of 1386. Okay, and that is indeed the correct answer. Let's move on to the next question. It says a committee of four people is to be chosen from four women and five men. The committee must contain at least one woman. Calculate the number of different ways that that calculate the number of different committees that can be formed. Okay, so I have at least one woman. So I know that there is a distinction between women and men. They're no longer, in the same category. I want the distinction between them because there's a restriction involved that I need at least one woman. So how many women do I have available? Four and five. So at least one woman. That tells me that if I need a total of four people, that should be three men, two women, and two men, three women, and one man, 4 women and 0 man. Okay, so I could say that these are cases 4C1 into 5C3. 4C2, I will have to add all of these cases together, 5C2. 4C3 into 5C1. 4C4 into 5C0. Okay, now it's going to be intelligent if I write the totals individually first and then I add them together. You will often find this in the marking schemes as well. That's 40, 60, 20, and 1. So I get 121. Okay, that was the second question. Let's move on to the third question. It says a committee of 5 people is to be selected from 6 men and 4 women. Find the number of different ways in which the committee can be selected. Okay, so there are no restrictions involved right now. I've told you nothing about men and women separately. So there are no restrictions. There are just a total of 10 people available, and I want to select 5 of them. So I'm just saying 10C5. Let's see if we get the correct answers out of the calculator. That's 252, and that is indeed the correct answer. Then in the second case, as I say, that the number of these selections with more men than women. So I'm going to write men and women. More women than men, sorry. 6 and 4. So I want more women than men and I want a total of 5 people. So what is the maximum number of women that I could have in this committee? Okay, so 4 and 1. Okay, I can't have 5 and 0. Why? Because 5 women are not possible. You cannot have 4C5 because n always has to be greater than the number of objects that are to be selected. Okay, then I could have 3 and 2. Okay, I couldn't have any other case here because 2 and 3 would not give me more women than men. So 6C1 into 4C4, I keep multiplying till my committee is complete. Then I add the second case 6C2 into 4C3. Okay, so I think that gives me 6 and that should give me 60. Yes, that gives me 60. So total is 66. I think that's simple again. Let's look at this next question. It says the music student needs to select 7 pieces of music from 6 classical pieces and 4 modern pieces. Find the number of different selections that she can make if there are no restrictions. Again, when there are no restrictions, it's a simpler question. I can just say that it's simply I have 10 pieces together and I want to select 7 of them. So 10C7 gives me 120. Then there are to be only 2 modern pieces included. So classical and modern. So I have 6 classical pieces and 4 modern pieces. Okay, I can only select 2 modern pieces. That means the all the rest should be classical pieces. So 5. Okay, so I get 6C5 into 4C2. Okay, let's see if that gives us a correct answer. There's no other case to it. I could have done this directly as well, and that's my choice. But right now, I'm dealing with a particular pattern of questions. So I'm writing them all in the same way. Okay, so that gives me 36. Then part C is a lot of marks. There are to be more classical pieces than modern pieces. So now what I'll have to do is I'll have to think about cases again. So I on top I write the total number that are available, 6 and 4. Now let's think about more classical pieces and modern pieces. So let's start with 7, but 7 is not possible for classical pieces. So I'm just going to go with 6 and 1, 5 and 2, 4 and 3. So that gives me 66 into 4C1. I think that should be 4. 6C5 into 4C2. Let's check what that is. 36, then 6c4 into 4c3. Hmm, 60. So that gives me a total of 100. Okay, that was another question. Let's make this a little more complicated. Now, this is actually an AS level math question. The rest of the questions that you did were from basically O level ad math. So this is something that you need to be aware of. And let's do this together. It says an examination paper contains 12 different questions, of which 3 are on trigonometry, 4 are on algebra, and 5 are on calculus. Candidates are asked to answer 8 questions. Calculate the number of different ways in which a candidate can select 8 questions if there are no restrictions. Okay, so 12 different questions. I just want to select 8 of them, and that should give me the final answer. There's no difficulty there. Okay, part B. The number of these selections which contain questions on only two of the three topics, trigonometry, algebra, and calculus. Now I have to put out that division first before I can go on. Trig, algebra, and calculus. Okay, I have a total of 3 trig, 4 on algebra, and 5 on calculus. Now I can select only 2 out of the 3 topics. So I can either do trig and algebra and trig and calculus, or algebra and calculus. Okay, and I also need to remember that I still need to select just 8 questions out of a total of 12 questions that are available to me, but in different categories now. I am fixed in those categories. I cannot change those categories now. Okay, so first I think about trigonometry and algebra, but you see the trigonometry and algebra add up to 7, 3 and 4 add up to 7. I need a total of 8 questions. That presents a problem, and which means that I cannot just do trigonometry and algebra on the exam. I cannot go on and do trigonometry, algebra, and then select one from calculus, because the examination has a restriction that I can just select 2 topics out of 3. So I cannot do trigonometry and algebra. This cannot happen. 3, 4, and 0 cannot happen. Okay, why? Because it doesn't meet the total number of questions. The total number of questions must be 8. Okay, so I think about, then let's say, can I do 3, 0, and 5? Yes, that sort of fits. So I'm going to write 3c3 into 5c into, you can write 4c0 in the middle, but 4c0 should be 1. Anything c0 is 1. Remember that it's not 0, it's 1. So that gives me 1. Okay, then let's talk about, let's keep trigonometry as 0. I couldn't combine trigonometry and algebra. Now let's talk about algebra and calculus. Okay, so I could select 4 from here, and I could select 4 from here as well. Okay, so that should give me 3c0 into 4c4 into 5c4. Okay, so that gives me, I think, a total of 5. Then there's another case, 0, 3, and 5. I could change the quantities as well, and that should give me a different combination. So I could say 3c0. I don't need to write 3c0, but I'm just writing that for the sake of completeness right now. 5c5. That gives me 4. So a total of 10 different ways of attempting this exam. The number of these selections. So there are 10 different selections that the students could have done in terms of attempting the question. So when the teacher is actually making a marking schemes, they need a set of 10 different combinations of marking schemes to be able to check all the questions that are there, and to sort of have a different marking scheme for every student that is there, which I want to send out the marking schemes. Okay. Let's talk about this one. There is also an AS level math question. It's 5 marks. Let's see what it says. There are 7 Chinese, 6 European, and 4 American students at an international conference. 4 of the students are selected, are to be chosen to take part in a television broadcast. Find the number of different ways the students can be chosen if at least one Chinese and at least one European student are included. So there's a restriction. So let's first split them up. Chinese, all of them have restrictions. European and American. Okay, seven Chinese, six Europeans, and four Americans. Let's talk about the cases at least one Chinese and at least one European. And I want to select how many, find the number of different ways the students can be selected. Four of the students are to be selected. So I need a total of four. So I can go one, one, and two. One Chinese, one European because at least one has to be there. Then I can still say one Chinese, two Europeans because at least one European. And I can reduce the number of Americans. I can also say one Chinese, three Europeans, and zero Americans. Okay, that's all those combinations that have one Chinese student. Okay, Europeans are changing and Americans are changing. Americans don't have any restriction, but Europeans and Chinese do. Let's make the Chinese two. So two, one and one, two, two and zero. Okay, because I cannot make the Europeans less than one. So I have so many different cases now that I need to work out. 7C1 into 6C1 into 4C2. 7C1 into 6C2 into 4C1. 7C1 into 6C3 into 4C0. 7C2 into 6C1 into 4C1. 7C2 into 6C2 into 4C0. Okay, let's check what we get. I get 252 for the first one, 420 for the second one, 140 for the third one, 504. So 5 more questions. It's going to take a while. Let's check if we have all of them equals to the answer that's there. Okay, there is one case that I have not written. Yeah, that sort of reminds me now. But I could have three Chinese, I could have one European and zero Americans. So 7C3 into 6C1 into 4C0. 210. Yeah, that is the total. That's 1841. Okay, so that's another case in combinations. Then question number 7, it says a committee of 6 people is to be chosen from 5 men and 8 women. In how many ways can this be done if there are more women than men on the committee? So this is like an old question. Okay, let's do it in the same way. More women than men. So 6 and 0, 5 and 1, 4 and 2, and 3 and 3 can't be possible. So 5C0 into 8C6, 5C1 into 8C5, 5C2 into 8C4. Hmm. 1008. Okay, so that's the total number. Let's talk about the next question that has a slightly different concept, and we are going to talk about that. If the committee consists of three women and three men, but two particular men refuse to be on the committee together. Okay. Now, whenever you have such a case, what you need to think about is now how many different categories of people do I have? There is a particular man 1, PM 1. There is a particular man 2. There are other men, and then there are women. Okay, what is happening is let's first write down the totals. 1, 1. How many other men? There are 3 other men because there were a total of 5 men. I've separated 2 men, so that's there. And I have 8. Now I know that I need a total of 3 men. So either this person could be here, 1 and 0, and then I could have 2 other men, and then 3 women are fixed because that's what the question says. Okay, then I could have 0 and 1, another 2 men, and then 3 women. But I could also have a case because those two people are fighting. I could leave both of them out and just select this. Okay. So what do I get? I get 1C1 into 1C0 into 3C2 into 8C3. Okay. 1C0, 1C1. It honestly doesn't matter if you write 1C0 or not because it's going to be 1. Okay. So that's 8C3 into 3, 168. That's also 168 and 56, 392. Okay, that is the case. Those are the questions about combinations that I had for you. Remember that on the exam you have to keep these ideas separate whenever you are selecting councils or committees or teams or just selecting peoples or letters. You always use NCR, and that's the key to figuring out these questions. A lot of people end up being confused as to whether it's a combinations question or whether a permutation is to be done and so on. We're going to do this step by step in the next few videos that I have for you. Please make sure to like, subscribe, and comment, and keep watching these videos till I complete the chapter so that you get an idea of the entire chapter and how to separate questions. And then we're going to have some recent questions as well in the last video or so. And I'm going to solve those with you. Thank you for watching, and I'll be back with another video.